Hello, good morning everyone. My name is Lily from PC System. Today I will show how the new function of the Minitab 20. And before we start the session, make sure you can see the screen and also hear my voice. If you face any problem, later you can type in the chat room. Then I will answer your question after I finish this demo. Okay. Because today I will record the video, so I will mute the sounds. So let's say you have any questions, I will answer later on. Okay, before we start the web demo, let me introduce the Minitab 20. So Minitab is the leading statistical software for quality improvement and statistic education worldwide. Thousands of distinguished organizations rely on Minitab 20's powerful capability and ease of use, including American Express, Pfizer, Coca-Cola, Microsoft, eBay, and IBM. The world trusts Minitab for quality. So for more information, you can visit our website www.minitab.com. Minitab was originally developed in 1972 at Pennsylvania State University. We built this software because we want to help professors teach the statistics concept using computers, so students could focus on learning statistics concept rather than on performing manual calculations. So when we use this Minitab software, we no need to remember the formula. How to apply the formula also no need to remember. We just remember how to choose the right tools and how to interpret the result. So this can save a lot of time to do the analysis and also make the user more confident. So Minitab is an all-in-one statistical graphical analysis software. So this is a one package. After applying the Minitab, this can help you to reduce the waste, increase the profit, and also raise the quality standard. So these are the popular function in Minitab. So this is called DMAP methodology. Okay, D stands for define the problem. M stands for measure. A analyze. I improve. C control. So we can define the problem use these tools. For example, use the Pareto chart, control chart, capability analysis, graphics to define the problem. So for example, my PPK reading is less than target 1.33. So based on this situation, we can form a project. And next measure. So we use the gauge and out. So before we do the analysis, go to the improve. We must make sure our data can be used. We must trust our data before we go to the analysis. So we can go to the gauge and out. A stands for analysis, so we can use the hypothesis, ANOVA, correlation, regression, and graphic to study the relationship between the variables and also build the models. Next is called I improve. Then we can do the simple experiment like ANOVA, regression, design, or experiment randomizer. So in this case, we want to study which is the significant factors, or we call important factors. So once I change the information of the significant factors, it will affect our output. So this is called improve. The last is called control. Control our process. So after we find the formulas, the best models, then we can apply to our process, then monitor our process. So we can use the control chart, capability analysis, and reliability analysis. So these are the common tools in Minitab. However, today I not cover this one in details because today we focus on the Minitab new functions. So there are many companies rely on Minitab powerful capability and ease of use, and they come from the different industry. For example, for automotive, electronic, medical device, pharmaceuticals, service industry, and so on. So here I just show some example. Besides Minitab, our company also provide other programs. For example, the SPM is used to run the predictive modeling. Quality Trainer is the e-learning software. And Workspace companion by Minitab. Okay, so this is used to manage your project, like Sigma project. And we also provide the training. We provide the on-site training and also the public training. And also we help the user to run the program, like do the automation project or consulting. Last and not least, we also provide the technical supports. So for example, you face the installation problem or you want to check certain function in Minitab, so welcome email to us. Okay. So now we go to the Minitab 20. So now the Minitab 20 we can access for nearly any device. For example, can use your phone or use the laptop or desktop to access the Minitab. Because Minitab provide desktop app and UI app, so we can export and import the data from Google Drive, for Microsoft OneDrive, or from local files. So I show example. Okay, so this is the Minitab desktop app. Okay, desktop app. So we can get the data from Google Drive or from Microsoft OneDrive. And we also provide web app. For example, okay, so this one I just go to the website, then I fill in the information. And fill in the password, sign in. Okay, so this is the test. This is the web app. So we can log in the complete analysis, then find the insight and find the better decision, no matter where you are. For whether you are in the office, at home, or halfway around the world. So this web app, you can open the mini project. So even this PC, you are not installed the Minitab license, or you still can log in this one. Just make sure you have the Minitab account. This one also can use the other device. For example, use a phone to log in this. Then we can open the data from Google Drive or OneDrive or local file. Okay. So this is the first difference. With the Minitab 20, we provide the web app. Okay, so next one, Minitab 20 also provide the new graph. This is called heat map, bin scatter plot, parallel coordinate plot. So now I show one by one. So the first one is called heat map. So we use the heat map to investigate the relationship between one or more categorical variables and summary statistic. For example, we can display the sum of average, standard deviation, and so on. So the summary of statistics that you select determine the color gradient of each rectangle. So when you have a large number of factor level, the heat map may be easier than the bar chart to communicate the areas that are different. So the benefit of use the heat map, this can enhance the communication with a target audience and the ability to drive valuable insight from vast data set. So now I show example. So this user, they want to determine how the virus spread through the populations of 4 different regions. The number of infections will record each day for 6 months. So for each region, the number of infections are split into 2 age categories. So now we can go to the Minitab. Okay, so this is the Minitab 20. So I explain a little bit about the overview. So the first show, this is called menu bar. So we can call the function from the menu bar. For example, file, we can open the new project or open the existing project, save. If you want to run analysis, we use the stat, graph, and assistant. Okay, stat, graph, and assistant. And second row, this is called toolbar. So toolbar is a shortcut to call the command. And navigator is used to save your output name and help you to manage. Then this is the output window. And below here, this is the worksheet. Okay, so this is the worksheet. So now I open the new project. Okay, so we can go to the file open, then get the data from the local drive, and also can get the data from the Google Drive or OneDrive. Okay, so now we look at this data worksheet. So this data worksheet, you must save the data in the column base. Okay, column base. The first column is called column name, and this is the data. So from here we can see we record the month, region. Okay, so there are 4 regions here, and the age group. So the age group that's split into 2 categories: the younger population and the senior populations. Okay, and this is the number of infections. So in this case, we have 5 digits of the data. So it's a very huge numbers. So in this case, traditional, we show the table. Okay, so this function we can find in the previous versions. Okay, so in this case, we want to find the relationship between these 4 variables. Okay, so we fill in the dialog box. Take out the count. In this case, we want to find the total number of infections. Okay, okay. Okay, I show again. So in this case, we want to study the relationship between these 3 categories compared with the total infections. So in this case, we can go to the stat tables, descriptive statistic. Okay, so the row I show the region and age column, so it's a month. And go to the categorical variables, take out the counts, and this fill in the infections sum. Okay. Then we look at the upper window. So if you want to edit your output, you can go to the navigator. So we can right click. For example, we can send the result to Word, PowerPoint, Companion, and Workspace, and also can send to the report. Okay, so now we can look at this result. Okay, so this table shows the relationship between the month versus the locations and the age group. So the star means there are no value in these categories. Okay, not in these categories. And now we look at the first value, 17207. So this is the total number of infections in the younger populations of the Midwest in the March. So the total number is 17207. Okay, so here we provide the summary. Okay, so this is the total numbers. Okay, total numbers. So from here we can see very obvious the West is the only region get the reading on January and February. Okay? Then other region, they are not collected data in these 2 months. Then probably this is due to limit or testing. After this, we can look at here, we want to find the max. But because here we have large number, so it's very hard to find the max. And also very hard to study the relationship between these 3 categories. So in this case, we can try heat map. So we can go to the graph heat map and fill in the dialog box. Then we press OK. Okay, I show again. So this is the new function in Minitab 20. So we go to the graph heat map and fill in the infections. So the function here will provide many options. So like this case, we choose some. And row variables, this one we can choose up to 5 categories variables. Okay, 5 rows. And the column variables a month, they also can choose up to 5 categorical variables. Then the gradient type. Okay, gradient type. So here there are 3 ways to set the colors of the rectangles. So first one is the divisions. So bins with the highest values are red colors, and bins with the low values are light blue is dark blue colors. And sequential for low to high, so they will use the bins with the high values are dark blue. The bins with the low values are the light blue. Okay. So this one then is reverse. Okay. Okay, so this one is just now I choose the first option. Let's say I choose from low to high. Then they will show from light blue. Okay, they will show from light blue until the dark blue. So now we come back to here. Okay, so this one is the heat map. We can use this one to study the relationship between the few categories, and which this bin is represent the values, the number of infections, so it's very low. And the bins with the high values, they are dark red colors. Okay, so heat map, so it's from very cool to very hot. So now we can look at this diagram. Okay, so first we can study the extreme values. So we study the extreme value. So we can look at here, the red color is from this. So the numbers of infections were highest in the older populations and the northeast in April. Okay, so very obvious, we look at this diagram, we can know which is the highest. And the second highest is this, and third highest. Okay, besides this, we also can see on the West is the only region that record a confirmed case in the month of January and February. However, we look at these categories. The number of infections exposed in the older populations of the Northeast in March and April is very high. So start from 0, then jump to the higher values. So probably this is due to the limit of testing. That's why they cannot record the data in January and February. So after we look at the extreme values, now we can study the relationship. This relationship. So we can see this is from very low to median. So look like the increasing orders. See, this one also is the increasing orders. And the south regions also increase in the younger populations from March until June. And June to July seen an increase in the south region. Okay, so this one is increase. Or probably this one that have a relationship. Okay, so this is use the heat map. We change the values. Okay, we change the value like this to be the color rectangles. So the heat map allows for the large number of data to be communicated almost instantly. And we mostly use our eyes to make sense of the world and not the color of the numbers. So we can use the heat map to study the relationship between the few categories. And we can look at the extreme values straight away and also can study the relationship. Okay, so this is the heat map. Next one I show is the Venus scatter plot. It studies the relationship between the pair of continuous variables when the data set have many observations. So previous study, the heat map is used to study the categorical data. So it means it's the group data, okay, attribute data. But this Venus scatter plot is used to study the continuous variable data. And this are also very good for the many observations. So traditionally, we use the scatter plot to study the relationship between x and y variables. However, when we use the large enough data set, the point the statistical plot can overlap and make it difficult to assess the distribution of the data. Venus scatter plot groups the data into the rectangle bins. Then the Minitab uses the the bin display either the density of the bins and the mean of the variables. So we go to another example. So we want to study the relationship between the MPG versus the field categories. So first one, we open the data set. Okay, so this is the MPG. So we record the car models and the field as variables, and our output variable is the MPG. So traditionally, if you want to study the relationship between the C2 and C7, we try scatter plot. Okay. Okay, so this is the scatter plot. So we show the relationship between the X1 versus the MPG. So in this case, we can look at here, this is the negative linear relationship. So once the weight increase, the MPG will drop. So this is the negative linear relationship. However, when we look at here, we can see this is the high density. There are many points in this region, and this is the low density. And another weakness of use the scatter plot is we cannot study the another three variables in the 2D graph. So in this case, we can try the Venus scatter plot. MPG C2. Then we press OK. Okay, so I show again. So we go to the Venus scatter plot. So same we fill in the y variable, so means the output variables and also the input variables. After this color of the rectangle, there are two ways to set. The first one is the frequency of binary data. So if this is the high density, then we'll show the dark red colors. If this is a low density, then we'll show the dark blue. Okay. And we also can include another variables. For example, I increase the displacement. So this one is include another variables. Then the color of the bin is depend on the mean of these values. Okay. Okay, so first one we show the Venus scatter plot. So this one we only study the relationship between weight and MPG. So if this is the low density, that will show the dark blue. high density, then we show the dark red colors. So very obvious that this is a high density. If you include another variables, for example, displacements, so in this case, the color of the rectangles color of the bin is depend of the mean of the displacement, the mean of the third variables. So in this case, we can see the weight and MPG is negative linear relationship. And also MPG versus displacement also is a negative linear. Okay? Because when MPG is high, the displacement is low. Then MPG is low, that means displacement is high. So also it's a reverse. Okay, so this is called linear scatter plot. Okay, so the third graph is called parallel coordinate plot. So this parallel coordinate plot is efficient way to visualize the multi-dimensional and multivariate data. So let's say in this case, let's say we have two variables, x and y. Okay, I received your question, but I answer your question later on. Okay, so first one is called parallel coordinate plot. So this is an efficient way to visualize the multi-dimensional and multivariate data. So in this case, we have two variables, so we can use the scatter plot. However, let's say we have 4 dimensions, for example, 4 axes. So the 2D plot is not enough. So when this kind of situation happens, then we can use the parallel coordinate plot. So how to get this? I use a simple example. For example, first one, we find the x positions of each points. Then we build a graph, put the location. After this, we find the y position of each point. Okay, then plot here. After this, we draw the connect line. So this is the two variable. After this, we include the third variables, and same we find the z position of each point. Then draw the graph and label axis. Okay, so in this case, let's say you have a lot of the variables, then you want to use the 2D graph show the relationship, then we can use the parallel coordinate plot. Okay. So we use the same case study. Okay, then we can go to the graph, parallel coordinate plot. Okay, I show again. So this is called graph. Then we go to the parallel coordinate plots. And here we have a few groups, so we can buy groups and fill in the variables. However, this variable cannot accept the categorical data. So like the C6 is the text data, so we cannot fill in here. And this Y skills, so we had the 3 ways to set, but I seldom use the original data because different, for example, like this case, the different axis, probably the scale is different. So if you use the original data letter, will be a bit confused. So normally I try the percent of range or standard unit. Okay. Then we can get the result. Okay, so in this case, we can see there are many lines. So this one will show, for example, the weight, the position of each point. So we draw the line and so on. Okay, so in this case, we can see the weight and dry ratio look like the reverse. Okay, when this is high, then dry ratio is low. When this is weight is low, dry ratio is high. So it's look like reverse relationship. And this also reverse. And horsepower and displacement look like no relationship. Displacement and MPG is that reverse. So like this case, let's say I want to find the highest MPG. So we can click the highest line. So we can see they will show the car name. And also show if you want to get the highest MPG, we should get a lower weight and the median drive ratio. Displacement and horsepower is low. Okay. So this is used a simple 2D chart to show the relationship. However, this kind of chart doesn't cover multicollinearity or other information. So we don't know which is the real significant factors. So if you want to study, then we still need to go to regression. Okay? But this graph good or use this graph is we can straight away to study the relationship. Okay. Okay, so now we come back to the question. Now, just now is about the business scatter plot. Okay. So when we use this function, let's say you have a large numbers. Today, because for easier for explanation, I use this example. But let's say your data set is very big. Okay, so for example, in this case, I want to buy the diamond. Okay. And in this case, I have a very huge numbers. Okay, huge number. So in this case, let's say I want to study the relationship between, for example, these two categories. Then the scatter plot will reach the limit. Diamond price color. Okay, so because here we have too many points, so it's feel like, yeah, I can see some colors. Let's say I use things. Okay, then if you have a large numbers, then use the scatter plot. We cannot see the very clear relationship. When this kind of situation happens, then we can use the binary scatter plot. Because they will show the high density, they will use the direct colors. Then the low density, for example, this region low density, then they will show the dark blue colors. So it's more easier to get the information from the binary scatter plots. Okay. I hope I answer your questions. So let's say you use a very huge numbers, then we prefer use the binary scatter plot. Okay, so just now we come back here. Okay, so let's say I want to find the relationship. Normally I will try the regressions. Stat regressions, field regression models. And fill in the MPG and also cylinder. And go to the stepwise. Okay, so I repeat. Let's say I want to get the models that know which is the significant factors. Okay, so we can use the regressions. Okay, regressions, fit regression model, and fill in the dialog box stepwise. So here provide a few methods to clean the data and also get the final models. Okay, so you can use the stepwise forward or other informations or like validations. Okay. But in this case, because we use a small data set, probably we use these three methods better. But if your data set is very huge, for example, you have few thousand data, then we can use the forward selection for validations or criteria. Then after this, we can get the final models. So just now the diagram, it just gives you some information about the relationship between data. But let's say you want to know which is the significant factors, then we still come back to the regressions. Okay. So okay, so now I expand the last topic. Okay, so this is called classifications and regression trees. Okay, so this function also is used to find the relationship between the input variable and the output variable. Okay, but this one they will use the simple diagram. It's used look like the tree diagram to study the relationship. And this is one of the methods in the machine learning. So machine learning is the model statistics plus computer science. So they can study the big data. So the machine learning algorithm use the computation methods to learn the information directly from data without relying on the predetermined equations to models and then make the prediction and decisions. So machine learning, actually there are many methods. There are supervised, unsupervised, and so on. But today I focus on this cut. So the classifications, classic statistical techniques such as linear regression, logistic regression can struggle with these issues. But the machine learning that can overcome the problem, they can solve the problem and also able to do this automatically. For example, everything is statistical significance. For example, now I have 10 x variables, then all become significant. Then we'll worry, this is the right models or not? So in this case, we can try cut. And also sometimes we have the issue like multi-collinearity. For example, S1 and S2, there's strong relationship. So in this case, it's very hard to take out the insignificant factors. And also sometimes we'll face a problem like outliers, many missing values, or the data is not normal and so on. Okay, so when we use the cut, then we don't need to worry about this problem. So this cut is introduced by the statistician below in 1984. So the cut is the decision algorithm that can be used for both regressions and classification problem. So means your output data is continuous data or the output data is attribute data. Both can use. And cut is the only decision tree methodology that use the original code from the statistician below. So now I explain the ideas about the cut. So the main idea is divide the data, or we call partition data, into the different regions, so we can know the relationship between the dependent variables and we can predict them more accurately. So for example, in this case, we have a few points, the rectangle and circles. So we want to classify an observation as either a triangle or circles. So in this case, this one is very simple. We can use our eyes to make the decisions. But imagine if you use the PC, you use the machine method. So the machine the PC need to determine the cell. Okay, so which region can find the rectangles, which region can find the circles. So we use this cut. So now I explain the basic ideas about the cut. So here there are 5 rectangles. So this rectangle is called nodes. They are the building block of the card decision tree. So there are 5 nodes in the card tree. The third one is called root node. And this is called speed. So we have two speed, x2 minus 0.49 and x1 less than 0.24. And if this node that have the two speed, two child node, then this is called binary speed. And the last one, this is called terminal node. So we have 1, 2, 3 terminal node. And the node is a pure, so like this, then don't have the child node, then this is called pure. Okay, then after we get the decision tree, then we can want to find the rules. For example, now we want to classify either triangle or circles. So if x2 less than equal minus 0.49, then the predicted class is circles. So like this case, okay, you can see the x2 is less than minus 0.49. So this region circles, so 100%. So x2 greater than minus 0.49 and x1 less than 0.24. So the predicted class is the triangles. So we can look at this diagram. It's higher than x2 and also less than 0.24. So this region is triangles. So it's around 85.7%. So if x3 greater than 0.49, x1 greater than 0.24, the predicted class is circles. Okay, so for example, now I have a new data, x2 minus 0.2 and x1 equal to 0. So we can put the information to diagram, then they will know the probability class is the triangles. So the purpose of we do this is we want to get these rules. And this kind of the decision tree, this card tree is more easier than the traditional methods like regression and ANOVA. Okay, because we look at this diagram, then we can make the decision. So the user, if they don't have the very strong, they don't have the knowledge about the regression and card, it's fine. They still can make the decision based on this card tree. Okay, so this is how we get the card. Okay, so Minitab will auto build a few trees. Okay, few trees. This is automatically. Then after this, the Minitab will auto select the best one. They use the validation with the test set for cross validations. They use this method to find the best. Okay, so today we go to the one examples. So now we want to study the information about the factors or that affect the heart disease. Okay, so now in this case, we have a few categories. We have 13 X variables, and this is our output variables, yes and no, and total around 300 data. Okay, so if you have a lot of data points, we'll face a problem. For example, probably we have missing values or outliers and cannot meet the assumptions. So in this case, we can try the predictive analytics. And this predictive analytics is split into two groups. If your output variable, like this case, yes and no, then we can use a classification. Let's say this is the regression, for example, the speed, time, then this is under regression. And in the dialog box. Okay, so we fill in the dialog box, then we press OK. Okay, so now we can look at the result. So the first part, they will show the methods, and the second table, they will show the information. So the heart disease, the class is yes, is around 45.9%, and no is around 54, so it's around 50%. This one, it will show a lot of the trees, and needed I select this one. So this is a 4 terminal node. So if you have 4 terminal nodes, then you look like this. Okay, so we have 1, 2, 3, 4 terminal nodes. So let's say we want to try other trees, then we can click select alternative trees. Okay, so in this case, they will show the examples. For example, now is the default setting. So default setting will not choose the lowest misclassification cost. Then because we prefer to use the simple models. So we use the one standard deviation errors of the tree that minimize the values. Okay, then we choose this. Okay, so let's say I want to use other trees. For example, we can choose 7. Okay, so they will show the examples and also show other informations. Change. Okay, so normally we would prefer to choose the simple tree with the lower cost. So let's say in this case we try 7 nodes. Okay, create 3. So here they will show that now we choose the another tree. Okay, but for easier to interpret the result, now we try the 4 nodes. Okay, so first one we look at the root node, the first rectangle. So in this case, the blue colors represent the event means that someone has a heart disease. The red item means that someone don't have the heart disease. So here we'll show the summary. After this, they will speak by the THAL. So this is the Italian heart scan. This is the Italian heart scan. So if it's normal, then they will come to this node. So it's around 38. So it's around 22% they have heart disease. If the scan is fixed or reversible, that means the heart disease is 74. Okay, so this one means they're very high. Okay. Okay, so here will show a lot of information. So let's say in this case, I want to know the heart disease 85%. Yeah, it's this one. So we can click. Okay, so once we click here, that will show how to get this terminal node. Then we can right click, copy the rules. Okay, after we copy, so let's say we come to here. Okay, so let's say I want to check the probability the heart disease. So we can look at here. So they will show the highest is for this. And when the scan is normal, the measure versus greater than 0.5, and the chest pain time is greater than 3.5. Then the percent to get the heart disease is around 85%. Okay, so this kind of the country is more easier to deliver your ideas. So let's say you want to deliver your idea to the management who don't have the very strong statistic knowledge. Then this is very simple. After this, we can go to the relative variables importance. So the higher is the change pan time. So it's around 100%. Then the next important variable is the measure rest. So it's 86.5% as important as the first variables. Okay, so this is the second important. And third and so on. Okay. So these two actually on this field they are very small. Actually we don't need to care about this. After this, another important point is the ROC. So this ROC curve is indicate whether the classification tree is good. So ideally, we hope to get the value close to 1. Okay. So in this case, my result is close to 0.8 to above 0.8. So this is considered very good. So for example, ideally we hope. Okay. So this one is study the region error curve. So it study this region. So we hope this region is higher, is close to 0.1. So if close to 0.1, that means this is the good models. Okay, so after we get the models, now we want to predict. So we can go to the bottom, predict, and we can fill in the informations. Okay, so let's say I save time, just fill in 3. Save time. Okay, maybe I try again. Okay, sorry. To save time now, I already fill in the, just now we go to the predict, then we click the individual data, then I fill in the age. For example, now I'm 35 years old. Okay, so after we fill in here, then they will show the result. The probability to get the heart disease is 0.11. The probability to cannot get the heart disease is 0.88. Okay, so this right straight away then tells the percentage and probability. Okay, so these functions apply in this is start from median 19 point, I can't remember. Okay, start from the 19 last versions. Okay, so actually it's a very useful functions. Okay, so now I open Q&A. I mute all. Okay, another question is I installed the Media 19. Okay, use the corporate license. So can I upgrade this to the Media 20? Okay, so if Media 19 jump to Media 20, then it's chargeable. So it means your company need to pay the upgrade fee. Okay, upgrade fee, then you can use the Media 20. But let's say you use the, okay, for example, now is product version is 20.1.1. So let's say Minitab in future upgrade to Minitab 20.3. Then this is free of charge. Then you can update. Okay, so if 19 jump to 20, then it's chargeable. Okay, any other questions? Okay, so so sorry today I move very fast. Okay, so let's say you're interested about ideas about the Minitab 20, you can contact to us. For example, you can use our website or email to us, or you can follow us, use the Facebook link. Okay, so if no question, then we stop here and wish you have a nice day. The last question, is it the trial version? Yes, we need to provide the trial version. So you just go to the you go to the Minitab dialog, then you can enjoy the 1 month free trial lesson. Yes, we are record the video. Then after we finish this, you can we can share to you. Probably you write email to us, then we can share the link to you. Okay, so if you're interested about more about Media 20, you can draw email to us and also follow us. Okay, so that's all for the demo, and hope you enjoy and wish you have a nice day.